We have now covered equation of ellipses when they are centered at the origin at 0, 0. And they've had different major axes, right? They've had an x-axis major, where it means it's stretched along the x-axis. And they've had a major axis along the y, meaning it's stretched vertically along the y. Up until this point, it's only been x squared, y squared, meaning it's at the center. So now, my equations over here are x minus h and y minus k on either of these, meaning that center is now at hk. So you can see down here in the diagram, they're no longer right here at the origin, they're shifted. Pay attention to, just like with a circle, this is x minus h, and my center is at positive h. This is y minus k, and this is positive k. Same thing here, minus h minus k, and this is positive h, positive k. So you're always changing the sign. Once you change the sign, and you shift it from the origin, all of the other stuff really stays the same. Okay. You know, if the major axis is parallel to the x-axis, when your a squared, which is the bigger of the two, is under your x. You know when it is parallel to the y, when your a squared, which is again bigger than b, is under the y. Okay, so you know how I am with my highlighters. It's parallel to the x when a is under x. It is parallel to y when, when y is under a, or a is under y. Okay. I wish I would have highlighted that. That's really, really irritating me, but that's where we are. Okay, the other thing on this, these formulas here are still the same, whether the major axis is parallel to the x or y, and whether the origin is the center or the center is at hk. So those aren't changing as well. So let's get into some examples. Okay, and by the way, this right here is what your formula sheet looks like. All right, I've brought this up in the video a couple times. This right here is what you're going to be given. Parallel to the x information picture, parallel to the y equation picture information, and I have here that a is always largest, and then your b squared equals a squared minus c squared. While you're doing your homework, use your notes if you need them. But before you get out your notes and look at examples, see how much you can do from just this, because this is what you're going to be given on the test. So try to do your homework with what you are also given. Okay, now to our example. Example 5 says to write the equation of an ellipse, or for the ellipse. So right off the bat, I know my center. I know my HK is 4, 0. I guess we should write that as an ordered pair. Okay. We also need to make note of where our major axis is, because that's going to determine what formula we use. My major axis is parallel to the what axis? Is it parallel to the x-axis? Is it stretched horizontally, Or is it parallel to the y-axis? Is it stretched vertically? This one is stretched vertically. So it is parallel to the y-axis. So the formula that I am using then is x minus h squared over b squared plus y minus k squared over a squared equals 1. Because it is stretched along that y-axis, my a needs to go under my y. Okay, so from here, we know my h and my k. My h is 4, so this is x minus 4 squared plus y minus k. My k is 0, so this is just y squared. And it equals 1. So we need to figure out what is A and what is B. A is my major vertices. My major vertices are here and here. So how many units from the center to the major vertice is this? Well, it goes up 1, 2, 3, 4, 5, 6. So here by A is 6. And you can check the other way. 1, 2, 3, 4, 5, 6. And it's 6 the other way as well. So my A squared is going to be 36. So then come over here to your major or your minor vertice, which we label as B. How many units over is it? Well, it's 1, 2, 3, 4. B equals 4. You can check the other way. 1, 2, 3, 4. So this is 16. And so that's my equation. I don't care about C. I don't care about my foci. It's not labeled. And I don't need it to write the equation. To write the equation, I need my A and I need my B. Okay, example 6, find the equation of an ellipse with a center at -1, 2, one focus at -3, 2, and a vertex at -5, 2. Graph the equation. So let's plot these things. -1, 2. Okay, that's my center. I'll go ahead and label that as a C. One focus is -3, 2, so -1, 2, 3, up 2. That's a focus. And a vertex at -5, 2. Okay, so this tells me a great deal of information by these 3 points. I know my center is HK. I also know my major axis. Okay, my major axis is parallel to the what axis? Okay, if my center, my focus, and my vertice are all in a line stretching across that x-axis, this is parallel to the x. So that tells me the equation that I am using is x minus h squared over a squared because it's because it is parallel to the x-axis, the bigger number a needs to go under my x. Plus y minus k squared over b squared equals 1. Now I have some other information as well. This distance here from center to focus, that's my C. So if my C equals 2, I'll go ahead and do plus or minus 2 again. That's technically what it is. Then my c squared is 4. So from the center, I can go over another 2. And here's my other focus. And then, oh, there it is. Okay, and then from center to vertice, this is my A. This is 1, 2, 3, 4 units away. So my A is plus or minus 4. So my A squared is 16. So from my center, I'm going to go over another 1, 2, 3, 4. Here's my other vertice. So I do have my A squared. I have my H and I have my K. So what I am missing is my B. So let's use that formula of B squared equals A squared minus C squared to find it. B squared is 16 minus 4. So B squared is 12. That's what I need for here. So I'm just going to stop here for a second. And let's make our equation. It tells me to find the equation. I have everything I need. X minus H, my H is -1. So minus -1 is +1. All over A squared, which is 16. Okay, sorry. Plus Y minus K, my K is 2. Squared over B squared, which is 12, and it equals 1. Okay, there's my equation. So now I need to finish graphing, and to be able to finish graphing, I do need my B, because I need to know how wide or how skinny this is. So if B squared is 12, then that means B is the square root of 12. In a previous example, we've already done 12. 12 is 4 and 3, which is 2 and 2. So this pair of 2's come out. That 3 stays in. And we said that it equals something about 3.5. So I'll use this 3.5 from the center to go up 1, 2, 3, and some change right here. And down 1, 2, 3, and some change right here. So 1, 2, 3. I always start these off so bad. Goodness gracious. Hopefully yours looks better than that. Okay. So this almost looks like a circle. Why does this almost look like a circle? Because 16 and 12 are very close together. Right? You've got A that is 4 and a B that's 3.5. That's really, really close to being equal. So it looks like a circle. Okay, and then our last example, we need to find the center of the vertices and the foci of the ellipse and then graph it. We did something similar when we dealt with circles. When I had circles, it's general form. We had to complete the square to put it in the form that we liked. You're going to be doing this every single lesson. You can't get around not being able to complete the square with this. These are on your test at least twice, if not maybe even 3 times, being able to complete the square. I'll put the link again in the video, like towards the, go below the video where it kind of gives you the description to the link. If you don't know how to complete the square, you need to. And this, you need to know how to do part 2 of completing the square. And so that's what I'll put in down below where it says the description. Okay. You got to know how to do it. So clump your x's and your y's together. So I'm going to have 9x squared plus 18x, then put your y's together, plus y squared minus 4y, and I am going to go ahead and move that 4 over to equal a -4. Okay, when you complete the square, you have to have the square term equal 1, or like the coefficient equal 1. So the y squared's in the right form, but this one is not. So I need to factor out just the 9. I know with the x's, the GCF is actually 9x, but I only want to factor out the coefficient of 9. So that's going to leave me with x squared plus 2x. Now I'm going to leave some room here. And then y squared minus 4y plus, leave your room, and then equals -4. Okay. So we're going to do the same thing we did earlier. B divided by 2 squared. So my B is 2. So 2 divided by 2 is 1. 1 squared is 1. Here's where we make the biggest mistakes here. I am not just adding 1 to this side of the equation because of this 9. This 9, you're distributing back in that 9, you're multiplying, right? 9 times x squared gets me that 9x squared. 9 times 2x is 18x. But 9 times 1 means that I am actually adding 1 over here. Oh, I did the mistake we all make. I'm adding 9. I am not adding 1 because this is 9 times 1. So I'm not adding 1 to this side. I am adding 9. Okay. So then here, my b divided by 2 is -4. -4 divided by 2 is -2. -2 squared is 4. Because I pulled nothing out here, this is a +4. Okay, if you don't understand that, partly because I goofed, but if you don't understand that, watch the video of completing the square part 2. So this is x plus 1 quantity squared, because that's your b divided by 2, plus this portion here is y minus 2 quantity squared, because that's your b divided by 2. And then -4 and 4 cancels, this equals 9. Now with my ellipses, this always needs to equal 1. So I can get this to equal 1 by dividing by 9. And when I divide by 9, I have to divide everything by 9. So my equation, those cancel. I'm left with x plus 1 quantity squared. And if you want to leave it just like that, that's fine. But I'm going to put this over 1 so I can visually see what my A or B is. Plus y minus 2 squared over 9. And now it equals 1. So from here, I can answer these questions. Okay, so I need to name the center. And let me just write the, no, I'm not going to. Okay, my center is HK. So +1 makes my center at -1, and -2 makes my center at +2. I'll go ahead and graph -1, 2. I need my vertices, and my vertices come from my A. Your A is always your larger number. So A squared equals 9, which means that my A equals plus or minus 3. Because my bigger number is under my Y, that means that this is stretched with my Y axis here. So from this point, I'm going to go up 1, 2, 3. And I'm going to go down 1, 2, 3. These are my major vertices. And then this is my B, specifically my B squared, which lets me find my B. So from my center, I'm going to go over 1 in both directions. So I have enough information to make a sketch of my ellipse. So I can name my vertices here. My vertices are they're not 0, it's -1, -1, and -1, 5. And those are my ordered pairs there. I also need the foci, and that's C. So I will use my formula of B squared equals A squared minus C squared. B squared's 1, A squared's 9. So subtract your 9 over to get -8 equals negative C squared. Divide by -1 to get 8 equals C squared. So therefore C equals the square root of 8. That can be simplified. That's 4 and 2, which is 2 and 2. So this is 2. This is plus or minus square root 8. So this is plus or minus 2 square root 2. Now for graphing purposes, the square root of 8 is about 2.8. And I can check that I simplified right by doing 2 square root 2, and it's the exact same thing. So that helps me be able to graph it. So I'm going to go up 1, 2, and some change, and go down 2 and some change. Okay, so for my foci, these 2 points here still have the x coordinate of a -1, right? These 2 points, when you plot, you're still going -1, and then you're changing how much you're going up or down. So this is -1, and then you take this, and we would go 2, and then we would add 2 square root 2, and then 1, 2 minus 2 square root 2. Okay, sorry, I've got such a runny nose. Every time I pause for a minute, I've got literally snot drooping down my face. Okay. So we have found the center, we have found the vertice, we have found the foci, and now we have graphed it. This is always kind of tricky. One, you can kind of look at your graph and like I said, you know that it's -1 and you're changing how you're going up and down. And so what you're doing is you're going from the center, which is that 2, and you're adding square root 2 and you're subtracting square root 2. Also, from this formula sheet here, that's what's happening right here. You're taking, when you know it's parallel to the y, which is what this is, when it's parallel to the y, you could use this information where you know your h is going to stay the same. So in this case, right, -1 stays the same. And then you take your k and you add c, and you take your k and you subtract c. So use this as needed. Oh, and again, I mean, I've already said it, right? But when you're doing your homework, use this. You got all that information here. You got information, you got pictures, you got your formula. Okay. Use this on your homework. Take out your notes as needed. But try to use this and only this if possible. It's going to help you succeed better on the test.